The SimClim for ArcGIS add-in allows you to integrate climate change effects into your ArcGIS Pro toolbox. It allows you to generate spatial images of climate change impacts and explore those effects on your areas of interest. It leverages outputs from the global climate models produced by the IPCC. These models simulate weather patterns over time to estimate future climate under different scenarios. In this demo, we'll guide you through using the add-in and understanding its implications by examining the potential future impacts on transpower structures in New Zealand. First, I'll select a spatial area. I'll click the Browse button to choose the downloaded New Zealand Spatial Dataset folder. Next, we'll set a projection year and type. Baseline serves as a reference point to measure changes over time. For this dataset, the baseline year is 2005. I'll choose a future year of 2100 for analysis. A projection refers to a forecast or estimate of future climate conditions based on certain assumptions and models. Change from baseline measures the difference between the future period and baseline year, helping assess the magnitude of change over time. Next, I'll select a climate variable to analyze. For now, we'll focus on precipitation and wind speed to determine areas with the most extreme future conditions. Next, I'll select some climate models. When uncertain, selecting an ensemble of models is recommended. You can also generate optional low and high percentile outputs to visualize extreme climate events. Next, we'll choose the relevant months. It's important to specify the time period accurately, as it allows for the retrieval of peak values for specific variables, which can be particularly useful in contexts like climate analysis. Next, I'll choose from a range of shared socio-economic pathways. These scenarios help understand how different future social, economic, and environmental pathways might influence climate change and societal adaptation. Now that we've set all the parameters, we'll click the Generate button to start processing. The output will be a raster layer showing the values for the selected climate variable. Here we have the monthly averages for wind speed and precipitation. Now let's analyze the results. For wind speed, the results under SSP 37 show a projected increase in extreme daily wind speeds by the end of the century, particularly in central Otago. This increase is likely associated with stronger winds in the Southern Alps. And for precipitation, during summer we see little change across most of the country, except for Northland and Gisborne. In winter, precipitation increases in the west and south, reflecting stronger prevailing westerly winds. Using Extract Multi-Values to Point, you can pull raster values into your asset data, in this case, the transpower structures. Using Select by Attributes, filter your assets based on the climate variable values. This enables you to identify and showcase assets at high risk due to climate change impacts. With these insights, you can effectively use the SimClim for ArcGIS add-in to assess and manage the risks posed by climate change on your assets, ensuring better preparedness and resilience for the future.